Good day, everyone, and welcome to the Kalitika Lounge. Today, I'm going to be talking about the book that I wrote entitled The Mathematics of Disruption. So, I'm using mathematics as a vehicle to communicate the politics of science, the politics of technology, that in as much as we were taught that technology is a dogmatic subject, or even science and maths, that it's a rules-based entity that is rigid. But the real thing is that there are decisions that are being made. There are competing technologies, and you find that the ones that are capitalized, that have the support of capital or the support of the of the group that believes in a certain way, are the ones that win in the end. So you find that over the course of history, this has happened. For example, if you look at Tesla and Edison, there was the AC/DC war, and because Edison was quite funded, you find that DC took prominence. That is direct current versus alternative current. But eventually, alternative current won. That's why we have alternate current right now. But at the end of the day, it's about who is on the side of capital, who is politically correct, who has the support of the scientists of the day, and stuff like that. So this has happened to AI as well. So some of the things that we're seeing come out as AI is developing are not as a result of inevitability of technology, but it's as a result of decisions that were made. For example, if you look at the numerical precision of computer systems, you find that computer scientists chose the floating point system, and this was done for expedience, where literally we're saying that they chose efficiency over accuracy. So much that instead of taking a number like pi and using infinite decimal points, which is inefficient, they said maybe, okay, let's limit it to n number of decimal points. So that is a decision that someone came up with for the sake of progress. And we're not saying those decisions were wrong, but we're trying to actually just show that the progress of technology and science, maths, and other disciplines is dependent on the current politics, on the current trajectory of where things are, right? So you find, I was reading recently that Elon Musk, with Grok and I think for his bots as well, he's decided to actually drop the decimal points and use integers because it's far much more efficient. But obviously, it's at the expense of accuracy. But at the end of the day, you find that his models will be faster using less energy, but less accurate. So that's a decision that he made, and it's in his right. It's within his right to do that. But obviously now, when other people look at that, they shouldn't take it as gospel that you have to use integers or you have to use a limited number of decimal points because it was a decision that someone came up with. So I've seen this problem with a lot of students, especially after doing high school math, and then they go into statistics and find out that statistics, in as much as it's based on mathematics, it's based on it's actually based on decision making quite a lot, because there are so many decision points within the statistical learning theory, such that that's why statistics is abused so much, because there are a lot of decision points, right? There are lots of trade-offs that are made along the way, such that in as much as process-wise it might be correct, right? It might be auditable, reproducible, and stuff like that. But because there are so many human touch points within the process, that means that there's an element of craft, there's an element of art. So that's why I call statistics a pseudoscience. And obviously, data science is an offshoot in some way of both computer science and statistics. and it carried over with some of the decisions for expedience purposes that were taken in the past. So that means that that was carried over into machine learning and into AI eventually, because you find that now our LLM systems are based on correlations. They're based on deep learning, and that's a black box. And we chose to say, as long as we put an input and the output seems okay, we are fine with it. We don't have to know what the process is. That's what deep learning philosophy is. And that's why you find that deep learning actually gained popularity and momentum over Judea-Pearl's causal inference and other approaches that even Rubin's causal inference as well, that is the potential outcomes approach as well, because those ones needed rigorous understanding of why, but people didn't want to understand why. They just wanted to take an engineering approach to data science and AI, where they say, if we input X and it gives us a coherent output, therefore we don't need to know why. So that's why we find some of the gaps that are coming out in AI because of decisions that were made. So that's the most important thing that I'm talking about today, to say decisions were made to get us to where we are. That's why we have to make sure that the decisions that we make from here going forward are things that are going to improve the AIs, they are going to improve people's lives, are going to be fair, equitable, and enhance the understanding of these systems. Because currently, in as much as your chat GPTs and Claudes, they can craft coherent and very interesting prose, and they can come up with books and all of that stuff. They actually don't understand what they're doing. They are statistical machines that are using probability to calculate what the next word is and all that and all that. So in other words, some people have said, if you just take out the output from an LLM and use it, you are literally operating at the average, at the level of the average human being, because if it's probabilistic, that means that it's average, and you're using what is not the average, which is the model, right? Not the mean or median, but the mode, because it's frequency based. So if you don't want to operate as an average human being, then you have to operate in the edges now, those edge cases now. That's where now you find AI failing, because it cannot operate outside of its corpus, that is the data that it was trained on. It doesn't generalize well. In as much as they're trying to brute force everything and make sure that if they increase the data center size, if they increase the speed of the chips and stuff like that, but that thing has a ceiling. It won't get far as long as the systems do not understand what they're doing. So it calls for mathematicians, it calls for anthropologists, psychologists, neurologists, everybody to come together to say, what kind of systems do we want to build that can actually help us and move us forward as a species? So that is what I'm talking about in the mathematics of disruption, to say, how is it that we ended up with correlation-based systems as opposed to causation or causality, and key concepts such as also the fragility and numerical precision. That's the floating point one that I just mentioned here. Basically trying to understand the limits and potential errors, right, in numerical computations that can affect AI system reliability. So that's why you find now, when you ask ChatGPT the same question 10 times, it will give you 10 different answers. In as much as it might be pointing to the same thing, but it doesn't have the determinism that we need. So it's a non-deterministic system because of the probabilistic nature of the statistical machine that is pushing the AI. So that is the problem. And then when it comes to optimization, you find that there are certain optimization techniques like gradient descent that are being used, and Some are being used with information theory, right? So there are core principles for dealing with uncertainty and managing data within AI systems. So we need to make sure that probability, information theory, optimization, all these things are effective for us to move forward, right? And what does it mean for when we go into quantum AI as well? Quantum in the quantum world, if we are going in with things that are fundamentally wrong, that are not structurally stable, then going into more compute and more power in the quantum space, what does that mean? So we need to get our house in order and make sure that the systems that we're building are capable. And unfortunately, you find that our academics in Africa are not playing at the forefront, at the coalface of some of these technologies. They're not contributing enough to be able to, for their voices to be heard and for their voices to be taken into consideration. Because now, as with all the other technological revolutions that has happened, we Africans now have been relegated to being super users, or sometimes actually being the product and not being the custodians of the means of production, which is sad, because we can actually contribute more. We have unique insights, we have unique themes and stuff that we have as Africans that we could contribute meaningfully, so that these AIs will work for us just like they work in the Western world as well. And also just for sovereignty, we need to have sovereign AI. And for us to do that, we have to do it our way. And it doesn't have to be bigger data centers, bigger this, bigger that, more data, more data. People like Judea Pearl have spoken about understanding the structure of information, understanding the structure of cause and effect, means that we won't need as much data. And I think even the distillation models like your DeepSeek and stuff like that, they've shown us that we don't actually need as much data. We should invest in the difficult things like understanding, right, the causal AI and stuff like that, because that is going to help us in the future. It will help us protect the environment. It will help us not need as much capital, such that an entrepreneur somewhere in South Africa, somewhere in Kenya, would be able to also come up with their foundational model based on local data, localized information, and be able to service their own people without needing billions, like right now what we're seeing with the main players, where they are getting funding and they are burning money every day like it's Christmas, right? So we have to make these decisions. We have to challenge ourselves, especially as Africans and the general Southern Hemisphere, to make sure that we are not just consumers or the product, and we are at the forefront. So that is what we talk about in the mathematics of disruption. And I have even given out policy recommendations to the South African government. So I use South Africa as a proxy, but otherwise it applies anywhere, really, what I'm talking about. But for the sake of localization, I had to use 3 characters in the book, and they're moving from one landscape to the other. So I wrote it in such a way that it's a story where the students are asking the lecturer, and the lecturer is giving insight. So in so doing, we are getting to understand what is AI, what can it do, what can it do, what is lacking, and how can we possibly improve its performance, and how can it better serve us. And as a government, as a people in Africa, what is it that we can do in order to be active participants in the generation of this revolutionary technology? So you can go to akalytica.com /mathematics-of-disruption, mathematics of disruption, or you can just Google mathematics of disruption. You'll see the Akalytica page, and then you can get the ebook or the hard copy, and read and share, and just give your feedback, because at the end of the day, we are all we have, regardless of the geopolitics, regardless of other contexts. We should be able to contribute meaningfully to the discourse in AI and other technologies that will come as a result. Because you find, like right now, there's a big opportunity in IoT, because initially IoT was a standalone sensor technology that was getting information, but you find that on the analytics and usage side, post collection was not strong. But now with AI, it covers the whole value chain, such that I see IoT coming back from the dead because of AI and other technologies like Web3 and all that. So thank you very much for your time, and I hope that you're going to read Mathematics of Disruption and be able to make up your decision. And don't worry, you don't have to know mathematics for you to actually read the book. It's very easy to read. I made sure that even a child in grade 4 or 5 can actually read the book. So you should be able to read the book and share the knowledge. And also, don't forget to share how you are using AI, where you're using AI, how AI can work better for you. Share that in your circles, on your social media, as blogs, on Wikipedia, everywhere, so that at least we become participants to the generation of knowledge. Otherwise, we'll be left behind as well. So thank you very much. This is the Catalytical Lounge, brought to you by Edzai Zvobwo, and I hope to have more videos like this where we discuss different topics. So thank you very much.